structure, basically. Okay, what about this? What can you see here? It's actually made by taking 2 sheets of glass, putting some glycerine, oily stuff in between, and then injecting water and ink through a little hole, and then it fills out. How would you describe that shape, that blue, light blue shape? Seaweed?
Mold. It's mold exploring.
It is a bit like a lichen as well.
Yeah. The key features are these gaps that emerge. And they don't just, it's not like an ink blot. It's not like a normal ink blot. It has these funny gaps that sort of stick in to it. So its fingers going out, there's gaps between the fingers.
Why do you say the key feature is the gaps and not
To
the
me,
fingers?
just to me.
Okay. I think this is what's making me unhappy, is
Yes.
you're expecting us to see things as we do.
No, that's why I'm not saying anything until we'll have a go. This is actually a section of a lung under a microscope, part of the lung under a microscope. And how would you describe that image?
Interesting white spaces.
I would say it's frustrating because you have a first look at it and it looks kind of organic, but or it could be a mud pattern. You can't actually, and then there's this long break running down the middle of it, so you can't really classify it somehow. I think.
It's not something you normally see, it's a microscope image. So
It
that
was-
might be why.
It was almost more interesting before you told us what it was. Which I know sounds really, really silly, but I was trying to work out what it was. Along the lines of, the first thing my brain thought of was like dry ground. So like a muddy path that started to dry out and crack. And before you said what it was, I was kind of, wait, this sounds terrible, almost appreciating it more by trying to work out when.
It's more fun and it's a puzzle.
Yeah.
Good.
Okay.
But it's still not clear whether it's a white object, a black thing in between, or the black is the object and the white is in between.
Well, I won't tell you what this is then.
Lava.
It's a microscope that leads in a section. It's still like a microscope in this section.
A list of liquid colours.
A black and white photo of a ski mountain with rocks poking through.
Yeah, it's a geological feature after a sandstorm. It's got sand blown all over it and bits of rock and stuff.
Okay.
Coal heap and stuff.
Let's move on. I think the images.
What is it then?
No, I'm not going to tell you to. Not now. So what I'm going to do is talk about what the computer did. And the idea was to pick out the structure. So this is what I wanted to pick out of what you were saying. And I don't know if you can see, but what the algorithm did, this was the original, and all the sort of smaller features, the detail that you didn't care about, it's tried to remove those, and they're just shown in grey. And the important structure is kept. And these are tending to be the thicker parts have been kept. And the challenge was the tree trunk. And most of it's there, but even though there are these bits coming over it, we've managed to get most of the solid. And that's quite difficult. But what we're doing in a way is we're trying to get the sort of information out of the image that we see subjectively. Oh, it's a computer program. It's a little bit like Photoshop.
Yeah.
So you take a digital image. What it's got is it's got lots of little squares, and there's a 0 where it's black and 1 where it's white. And so you've got this table like to a computer program and it gives you another image that's been modified somewhat. And the purpose of the modification was to pick out the main structure and to hide the rest of it. And the stuff that's been hidden I've shown in grey behind, in black that got produced. So from this,
It's like using a filter in Photoshop.
So is it similar to a pixel? It turns it into binary, and then the algorithm kind of goes through and says,
that's right.
where there's 3 ones in a row,
Sort of like,
put it black. If it's a 1 on its own with no ones around it, put it grey.
yes.
Oh, okay.
Yes, that's the sort of thing it's done, with a slight difference that I'll mention at the end. But the idea is, to me the challenge was, when we look at this and we look at the structure, we see something definite, and we sort of ignore the other details. We're picking out the essence of it. We're perceiving the whole, and this is an attempt to process the image just to pick out that whole, to pick out the essence of it, the main structure, without getting distracted by details, those details being twigs on the outside, so we don't just end up with a big blob showing the sort of the envelope of the tree. And we don't want to get too distracted by the little ones in the front. We don't want this to make the whole tree trunk disappear. That's the idea.
Is the computation of this processing knows the tree?
No.
No. So it doesn't have a sort of a template for a tree and say,
No.
and it says, aha, this is something that looks like a tree, then it's a tree.
I'm going to play this game again. And there it's, to me this makes a little bit more sense than that one because it's picking out the main branches. So you can see that there's a 1, 2, 3, 4 sort of main clumps of tree here. There it's a little bit harder to distinguish. And that's not perfect. There are these thin branches where they cross over, that's me a big blob you don't really want. But for a fairly dumb algorithm, it's not too bad.
Is the image on the left, that's the original
Yeah.
analog?
Sorry?
Is the image on the left, is that the original analog image?
No,
That's-
that's black and white version. It's where you take the grayscale and you push it to be black and white. You choose, it's darker than a certain thing, it becomes black, otherwise it goes to white. But this image, silhouette, is fairly close to grayscale. Which it really is a black and white thing anyway, you see it. And the camera will see it as grayscale, it does not have that resolution. Let's continue. Right. What happens here is it's the same processing. What we're doing is we're picking out the smaller features, the smaller parts, together. So, what happens here is that the algorithms run several times to pick out features of different scales. And the darker ones were brought out first, you can hardly see them. And they correspond to very thin parts of the original image. So these here are those little cracks. And they're picked out as being small. And then the lighter it goes, the later it was picked out. And the challenge here is to try to get nice continuous sections so they don't sort of break up. And I'll show you how they break up. And again, this relates to the Gestalt idea, because you perceive that section as being a continuous section. This is a sort of a bit by itself, and there's a bigger bit. This is sort of one section by itself, and you don't want to have an algorithm that breaks it up into too many different parts, because that doesn't really correspond to the way you subjectively perceive it. We see not too many channels of a certain range of thicknesses, and we want the computer to respect the way we group it. For example, you don't want this to be chopped off into a thin bit here and a thick bit here.